right, 9:07. Let's start.
Good morning, everyone. If I can ask you all to just take a seat so we can get started. I'm Isla Berman. I'm the Dean of the School of Architecture here at UVA. And it is my pleasure to welcome all of you to the 2016 Woltz Symposium, Ecologies of Prosperity for the Living City, that has been developed and co-directed by Margarita Jauvert and Alex Wall, two of our faculty here at the school. They are both highly accomplished architects, urbanists, with a strong interest and expertise in landscape architecture, and who, of course, teach and work across the three disciplines in the school, or the four disciplines of our school. And they bring, I think, a critical interdisciplinary lens to the topic of this weekend's event, and are responsible, of course, for its conception. I want to thank them again, as I did yesterday evening, for bringing such an amazing group of scholars and designers to the school, and for all of their efforts in framing what will no doubt be a fascinating series of presentations and discussions today. I also want to again thank Thomas Woltz of Nelson Bird Woltz, a highly accomplished alumnus of the school and member of our foundation board, whose foresight and generosity has enabled this yearly event to be a platform for critical thinking and design discussions. I also want to thank Paul Weinshank, also an alumnus of the school and president of our foundation board, for his support of the symposium and also for his continued dedication and commitment to the school. As I mentioned yesterday evening, we are a multidisciplinary school with departments in architecture, landscape architecture, urban and environmental planning, and architectural and urban history and theory, all of which are in different ways dedicated to thinking and reshaping the city. As a school, we are also deeply engaged in the relationship of cities to environmental, social, political, economic, and technological issues, with projects by our faculty focused around the globe in sites in India, Africa, Asia, Europe, the Arctic, and the Americas. Projects such as those that many of you are familiar with, the Yamuna River project that evolved out of the Recentering Delhi studios, led by Iñaki Alde and Pankaj Virgupta. The Arctic Design Group, led by Matthew Joe and Lena Cho. The Biophilic Cities Network, established by Tim Beatley. Mona El-Kafif's work on public space and on urban metabolism. The African Urbanism Initiative, led within the school by Ellen Bassett and Nancy Takahashi and others. Alex Wall and Phoebe Chrisman's work on coastal cities, and Chichao Li and Esther Lorenz's work on Asian cities. Collectively, these represent only a small snapshot of the work happening within the school alone. And all of these faculty, many of whose biographies exist within the program booklets, and others of which you can look up, will participate in the discussions of the symposium today. As a way of both coalescing, networking, and building on this existing research and design expertise and the ongoing efforts both within the school and across grounds, we are initiating a Next Cities Institute focused on designing and rethinking global urban futures. Three critical paradigm shifts: planetary urbanization, climate change, and the accelerating advance of information technologies are fundamentally reshaping the city of the 21st century. Planetary urbanization refers to the fact that the vast majority of the world's 7 billion inhabitants currently live in cities, a percentage expected to substantially increase to 75% by the middle of this century. The effects of this phenomenon are enormous, given that the sustainability of contemporary urban life is responsible for 80% of the world's consumption of resources. Climate change and environmental pollution will have the greatest impact on these resources, while simultaneously operating to threaten cities rendered vulnerable by the fragility of inherited geographic conditions, and here I'm referring to things like coastal environments, or challenged by the socioeconomic dynamics and migrations of urban populations. While new megacities erupting at an unprecedented pace are transforming the landscape in Asia, rapidly expanding informal settlements across the global south and urban sprawl in the north are reshaping the city territory of the planet. Historic city models, including the 20th century automobile city and the planning, policy, and design protocols underpinning them, are increasingly unable to cope with these issues. These and other factors are rendering obsolete traditional planning techniques while demanding new methods of urban decoding, new forms of urban research, and the invention of a new toolbox of spatial and infrastructural concepts and strategies with which to reimagine and redefine the 21st century city. At the nexus of urbanism and ecology have emerged terms such as urban metabolism and the urban biosphere, asking us to rethink of cities as living and breathing organisms, understanding the effects of policy and politics, ownership and citizenship, the concentrations and transnational movements of capital, and the effects of migratory populations are critical to reconceptualizing the evolution and transformation of city territories on our planet. Today's discussion will certainly open a dialogue about these issues, one that I hope will certainly continue long after this symposium today, within the context of the school, and that will also help us develop and evolve the Next Cities Institute and its initiatives. I again want to thank Margarita and Alex for all of their work that they've done on developing today's symposium, which promises to be a phenomenal event. And I also again want to thank Thomas Woltz for his inspiration and support, and turn the mic over to him.
Real quick. Dick, I could have done that for you if you'd asked me. I know this room pretty well. Good morning, everyone. It is truly a pleasure to be here, and I wanted to just share with you a couple of thoughts about the day and a tiny bit of the history of the symposium. We're here today to have a conversation. 4 days ago, everything changed. The conversation is absolutely vital and critical. We can no longer relax, and everything that we do as designers is a political act. And I hope that the recent events will inspire us all to lean in and participate and work very hard to not allow landscapes of hatred or the invisibility of stories of our ecology and our culture that have shaped our planet. We are those stewards. Today's conversation has roots about 25 years ago in conversations with my father, who allowed this to happen. In his retirement, he started buying historic buildings in the small rural tobacco town that he grew up in western North Carolina. And he would renovate the buildings, and it greatly reduced rents, find young entrepreneurs to move in, to bring a life back to this dying town. He moved in a museum, cultural institutions, and young entrepreneurs that allowed the city to flourish again. And this was in retirement after having been an industrialist. I said, you realize you're doing preservation, urbanism, landscape. He's like, no, I'm just trying to take care of the people that raised me. And I said, well, that is community. And I continued that conversation, and then thanks to Robin Drips, Beth Meyer, Peter Waldman, and Bob Lasher, actually, who was the director of development about 20 years ago here, started a conversation about what the school was doing. And we were at the edge of an incredibly interdisciplinary conversation between planning, architecture, and landscape architecture. And I asked, in particular, Beth, what are the needs of the school right now? And it was a moment where there were not many faculty publications. It was hard to get funding for faculty publications. As you students will learn, those of you who go into academia, you need to publish. You need to find ways to expand your research and get the word out. At the same time, finding a way to grant students access to the most transformative thinkers in our world was very much on my mind. And so we created this idea of a symposium that would be funded to bring the speakers, just as today, to participate in the lives of the students, and very much the idea of conversation that Margarita and Alex have put forward, that this is a dialogue, was at the heart of the idea. But it was also at the heart of the idea to publish the the talks, publish the findings of this, so that a young faculty member might be able to gather peers and colleagues from around the world to explore their own research, and then have a book published that would capture that research to spread that word and build on for future generations of thinkers. This idea of research driving practice is something at the heart of what we're doing at Nelson Bird Woltz, and I recently was asked to make a presentation looking back over my career, and I was like, please don't, dude, do not ask someone in their 40s to look back over their career. That hurts. I'm not done yet. Hopefully there are another 20, 25 years to go. But nonetheless, it was an interesting moment to actually think about the phases of the practice and how research has driven making. I would say 19, 20 years ago, it started with research into this idea of conservation agriculture, which we'll hear speakers talk about today as well. This idea of rebuilding wildlife connectivity and looking to the biological sciences to influence the way we grow and cultivate the productive landscape. We have to grow food in ways that don't kill us. The second period of research really was in the next 8 years was about this idea of a culture to ecology to culture continuum, and how the activities of the planet 100 million years ago shaped and formed the culture that flourishes in cities today, and the unique identities of cities are rooted in this idea of a continuum from ecology to culture. And more recently, in the past 3 or 4 years, has been research into the invisibility of cultural landscapes, of enslaved people, the stories of women, the stories of the Maori culture in New Zealand, and now we're working with Aboriginal culture in Tasmania. So the idea that there is a spark, an intellectual pursuit that is then through work, research, labor, drawing, design made manifest is something that brings me to today, in that my hope for the proceedings and the result of this conversation is that there is a spark for all of the students and faculty here, that there's a spark in this dialogue that becomes the beacon for your own transformative experience as designers shaping a healthy and just planet. Thank you all for coming.
Hello, everyone. So, yesterday we were talking about conversation, and that's the main purpose of this symposium, is to set up these tables that are meant to sparkle conversation among the front row and the audience, as well as between the speakers and the front row. So, once that's said, I just wanted to spend a couple of minutes to speak about the title, Ecologies of Prosperity, and the fact that somehow Ecologies of Prosperity for us refers to the need of scaling down and readjusting urban systems to bring them more close to communities, resulting in a more biodiverse ecosystem that includes several scales. Urban systems such as agriculture would not be organized under the unique criteria of economical efficiency, but also organized in relation to its power to glue communities. As food production, other urban systems such as production of goods, water management, or trade would be recovered as multiscalar ones, performing as more biodiverse as a result. This reconstruction of multiscalar condition of urban systems would potentially lead to a more cohesive society with a higher sense of belonging and empathy, as a first step to face the political challenges of our large societies in the age of a new epoch inhabiting the biosphere. So one epoch, the Anthropocene, in which we start to be aware of the finitude of resources and the fact that we live in almost the same room, the planet. This condition urges us to reboot politics with the emphasis on ecology, understood as the management of the house planet. This was a discussion that happened in the Woltz Symposium team, and so we organized the tables in 3 categories, as you see here. It's an organization forced, and it's clear that all the projects, all the initiatives touch all of them at the same time, but that's an artificial way of organizing the talks that might produce synergies in between them. After these 3 tables, Table 1, Novel Synergies, Table 2, Instrumental Commons, and Table 3, Dispersed Concentrations, we'll move into Table 4, that is meant to challenge the audience and the front row towards some concepts that are the idea of moving from the planet of cities to the planet city, or from citizenship to planetcenship, or from ownership to usership. And lastly, how Universitas is playing this role of midway X. So that's the purpose of this debate, is to go table by table and then have a conversation all together at the end. However, after if each table, you will have opportunity to engage collectively. So that's all. Thank you.
Okay, we're coming up to time, so I will be very short. I thank Dean Isla Berman for already stating more clearly and explicitly what I was going to talk about. I'll just thank again Thomas Woltz, Nelson Bird Woltz office, with Tim Popa and David LePage helping us with graphics and general support. The Woltz Committee, so this has come together through two deans. Dean Beth Meyer begins it, and Dean Isla Berman is here on the day. The Woltz Committee, Julie Bargman, Chair of Landscape, and Yaki Aldai, Chair of Architecture, Thomas Woltz, and the rest of the committee, including Alan Lee, who handled all of our budgetary work. The job captains, Shannon Rule and Michelle Stein, and an expanded student team, with the help also of Callie Bryant and Cynthia Smith in the Dean's office. Those who joined us yesterday got a glimpse of the activist and passionate nature and power that resides in our student body. So we thank them, and among them we thank the students in the seminar that Margarita and I taught this semester, Concepts and Strategies for a Just, Resilient, and Temperate City. And have produced the visual concept stream, which we can see at lunch at the NOG and will be shown at the party tonight. Isla Berman mentioned the Next Cities initiative of the faculty, which comes simultaneous with the development of this symposium. So these two things coming together, creating a nexus of interest on the city and its territory. I won't repeat, but to say that while we were doing this work, we realized that developments in technology, society, ecology, economy, and demographics are accelerating faster than our political structures are able to manage them, faster than we are able to adapt, perhaps even in our teaching and practice. Therefore, we have to exploit the opportunity today and later the discussion about Next Cities as an accelerator to project us into this fast-moving stream so that we can not only manage it but guide it at its speed. I'll just say one word about the 3 sessions. The first one, which we're going to start straight away, is called Novel Synergies. Since this wonderful booklet explains everything, I'll be abbreviated in all my remarks about who's speaking, who the table is, and even talking about the sessions, but you might say that Novel Synergies, the word novel we have take from ecology, and we take it as the unbridled creativity and experimentation in ecosystems, which we also include, to which we also include urban development. So we are speaking about, when Marina Alberti talks to us about the science of cities, we're also speaking about ecology of cities, not ecology as a scientific study in cities, but the ecology of the cities, including urban development and including people in their actions. So synergies is what might happen as we consciously guide these streams together in our future work. Instrumental Commons is from the previous, partly undigestible title of the symposium, which was The Living City Reimagining the Commons for an Ecology of Prosperity. And I won't go into that because of our time, but commons, instrumental commons suggest the supple network of goods and services exchanged and shared with local but also global communities, and that this can be leveraged through the emergence of empathic power to create a just and resilient city. The network, the community, the spaces they need have to be designed. The appropriate form of governance might be a new democracy, as we'll hear from Jedediah Purdy later, but that relies on the intentions, values, and actions of citizens. The desired outcome is long-term sustainability, and I thank Nina Marie Lister for jumping in at this point and linking us to design when she writes, long-term sustainability sits squarely in the domain of human intention and activity, and thus design. So these apparently global or abstract or untouchable processes underway in the world are and can and should be the subject of our design. The last session is Dispersed Concentration, which is an English translation of a German urban planning term from the 90s. Urban development, the spreading out of cities across regions, has frankly baffled architecture and planning for the last 50 years. We hardly have a language for it, and that is agreed upon, and we must begin to both conceptualize, create the language, and begin to work with this. This is the form of the 21st century city on its own terms. So we're going to go straight into, I'm going to introduce the first table, the speakers. And let me just say something, we'll have two 25-minute presentations. Then I will ask the front row guests to come to the podium here with our speakers. We'll engage in a conversation for maybe 20 minutes, and then we'll turn the mics over to the audience for participation from your side. What does Novel Synergies mean? So we've cobbled this together, as I've said, from urban ecology, and in fact the work of Marina Alberti and Nina Marie Lister, as well as other scientists. And I think the question that we have is, can these out of urban ecology terms be used as ways of thinking and acting about the city? You can see that Marina Alberti is an urban ecologist in the Glaser Profession of Urban Environmental Planning at the University of Washington. She directs the Urban Ecology Research Lab, which studies properties of urban regions, which seeks the properties of urban regions that enhance their resilience and innovation. This is highly truncated, and she stands for a science of cities, the ecology of and not in cities. The title of her lecture and her book are cities that think like planets. And she'll be followed by Philippe Ram, who is the principal of Philippe Ram Architects in Paris. His forthcoming book is called A Sentimental Meteorology. There's several books in different languages about his work, which extends architecture from the physiological to the meteorological. His recent work includes the competition-winning 70-hectare, 154-acre Taichung Park outside of Taiwan, an office building at La Défense, and a convective condominium in Hamburg. And his title will be The City as Climate Modulation. So as the time marches on, I want to let the speakers speak for themselves. I'm going to introduce the table when we all assemble here so we can get going. So Marina, you have the word. So you have some water.
Thank you very much. Yeah, I'm set.
So you're there. Do
Yeah.
you know how to make the switch?
No,
No.
you're already done.
Okay. Margarita, can you help us make the transition here?
Oh, it's already made.
It's there.
Yeah.
Okay. You
Yeah.
ready?
Yeah.
Great. Yep, we're good.
Good morning, everybody, and thank you very much for having me here. I'm quite honored to be at this symposium and also very excited. I traveled from Seattle, and it was a long trip, but I really wanted to be here. Today, I'd like to talk about cities that think like planets, what they are, and how they can lead to a transition towards a resilient future. Let me start by asking you to imagine the future, specifically the future of New York City. Do we envision a future that follows the current trajectory of development? Will we cross thresholds, undergo irreversible changes due to climate change? Will the city be able to investing in green infrastructure? Or will the city be able to actually reinvent itself and its relationship with the environmental processes and systems? I came to realize that the way we think about the future has significant implication on how we act in the present and how we devise our strategies. But more importantly, what futures are we unable to imagine? I will argue that what we are unable to imagine are cities where humans are key players in natural systems and bio-cooperate, not just biomimic natural processes. Cities that operate on a planetary and also planetary, both spatial and time scale. Cities that rely on wise citizens, not just smart technologies. This is what I call cities that think like planets. But how can we actually build those cities? The emergence of a new urban science, which promised to be able to uncover what are universal rules of how cities work, and also the remarkable availability of real-time data and new sensors are key to envision such transformation. But science and data answer questions they were able to formulate. So my main question of this book and also of this talk is how can we expand our imagination to formulate new questions? In this talk, I will suggest 4 elements that reframe the question we are asking. First, I suggest the cities are not simply wiping out natural systems. They're actually changing the rules of the games. That cities are hybrid ecosystems, and that in hybrid ecosystem, resilience and evolution are emergent properties of those complex interactions that we can start to understand and analyze through urban science between social and ecological systems. And finally, also that cities is actually their critical state. They provide opportunities for innovation. One way in which cities are changing the nature's game is by driving microevolutionary change. Songbirds are getting tamer and bolder in response to urban environments. And they're also changing their tunes to keep the urban background noise from masking their signals. Recent study in Australia indicate that city spiders are getting larger and also do better than when they are in their natural habitat. They are more fecund. Seeds produced by weeds, they grow in our parking lots, evolved to have not to travel too far compared to those that live in the countryside. Earthworms are well able to tolerate contaminant in soils. Fish have adapted to cope with poisons like PCBs in urban waters. Fish, such the Pacific salmon, also have evolved a smaller body size. So the urban habitat is not simply altering biodiversity by reducing the number and diversity of species that live in cities. Humans selectively determine which species can survive with humans and cause organisms to actually undergo rapid evolutionary change. And those changes on individual and populations and community have effect on ecosystem functions, such as like biodiversity, nutrient cycling, water and air purification, and all those ecological functions on which human well-being depend. I pose two questions that are quite ambitious questions for science, which is, can the emergence and rapid development of cities across the globe change the course of Earth evolution? And can the patterns of urbanization, the way we build cities, determine the probability of crossing thresholds that could trigger abrupt changes on a planetary scale? I argue that if, as emerging evidence, and this is very recent evidence, is showing that rapid evolutionary change affect the functioning and stability of ecosystems, therefore, the rapid evolutionary environmental change that we're causing global urbanization may have significant implication for ecology, but also for human well-being on a relatively short time scale. Now, the humans through urbanization are causing microevolutionary change is not new. What is new is that evolution is happening on a rapid time scale. In the past, biologists and evolutionary biologists thought that evolution was taking so long to happen that our action would not matter on a contemporary scale. However, because of the rapid evolutionary change, there is a direct impact and potentially feedback on ecosystem function on a contemporary scale. So I developed a framework using evolutionary biology framework, and this graphic shows that in urban ecosystems, changes in gene frequencies may translate in phenotypic trait changes, and those may be physiological, morphological, behavioral, related to different types of species, from birds species to plants to fish, as I mentioned, that affect demographic rates and population dynamic in ecosystems, community structure, and ultimately ecosystem function. Now, to support my hypothesis, in one of my recent papers, I actually went through a lot of literature, and I'm not expecting you to look at in details at those kind of very detailed table. Here I highlight some examples. I already mentioned the salmon or the crepe Santa's seed and the earthworms. Another example, which is pretty known example of rapid evolution, is the water flea Daphnia, which is a common zooplankton in lakes and ponds. And I will discuss a little later the implication of that. Another example is the white-footed mice in New York metropolitan area, where the study on Muncie South shows signature of directional selections in urban ecosystems for those mice that are a critical host for the black-legged ticks that actually cause Lyme disease, which means increasing human exposure to Lyme disease. Another well-documented example of urban-driven rapid evolutionary change is the European blackbird, which shows differential migratory patterns and behavior in response to urbanization. So here I highlight some of the key biophysical and human drivers of change on your left: climate, demographics, economics, policy, which influence ecoevolutionary feedback and through interaction between the human and natural system here. And yeah, I'm sure I can't. And through a number of mechanisms, and I'll go in detail, like reducing native habitat, fragmenting the vegetation, also introducing novel disturbances, and selectively determine which species will survive and generating new biotic interactions. And also what we do, for example, through modifying vacant land or areas that are at the edge of our development, we are creating novel habitat. But in urban ecosystems, changing ecological dynamic are only part of the picture. What makes urban ecosystem unique is the presence of people and the pace of their social interaction, which cause such mechanisms as to accelerate. And one of the emerging phenomena that we are starting to understand is it's called telecoupling, the interaction between distance, nature, and human system, which not only expand the edge of the urban-driven ecoevolutionary change beyond the city itself, but actually accelerate its dynamic. Now, in a new study that has been just accepted, and I'm pleased to be able to talk about this today, just be accepted in the proceeding of the National Academy of Science, PNAS, which is a scientific journal. We have found that I worked with a team of ecoevolutionary biologists that are listed there. And we found new evidence on the mechanism linking urbanization to rapid evolutionary change at a global scale. We ask whether we can discriminate an urban signature of phenotypic change across the globe beyond the natural baseline and beyond what other anthropogenic changes are causing, and what are the relative impacts of different type of urban disturbance that urbanization causes. Here I show the map. We analyze a georeferenced database of phenotypic change, experimental and observational studies that report a total of more than 1,600 observations in many species of birds, fish, arthropods, rodents, plants, and algae across multiple regions, as you can see, of the world. And this map shows also the type of disturbances that are highlighted by the color of those dots. And on the background, you have the city lights. Now, I know I didn't want to, but I wanted to also, in some way, I didn't want to show an equation on a talk. in a landscape architecture department, but but I wanted to emphasize how important is that this study really was able to discriminate the emergence of distinct signatures using very sophisticated generalized linear mixed effect model, for those of you that understand that statistics, but primarily to emphasize that we're predicting very much the held down numerator is the phenotypic change, and we're predicting that taking into account all the other predictors, such as they have been used in the past to characterize those changes, such as whether we're genetic or phenotypic, whether the time of generations they took for the change to occur, as well as whether it was a natural or anthropogenic impact. And we'll also look at urban disturbance. And what I show here, with colors, so you may be able to actually appreciate this. We conducted what is an exploratory multimodal ranking and inference based on a known Akaike information criteria to evaluate the relative importance of each model and variables to actually predict that change. And each row in this graphic represent one model, and the height of the model represents the condition probability, and the predictor variable are shaded if they are included in the model. So pretty much you can see from on the right side that the urban disturbance pretty much is stable across all the models that try to predict the phenotypic change. This may be even more explicit. It's the relative importance of variables. And you can see that the most important variable predicting the evolutionary change of those species in the observations that we have studied are actually urban disturbances. By explicitly linking now urban development to what are the heritable traits that affect ecosystem functions, we can start to map what are the ecoevolutionary implications of urban-driven traits for species that play important role in ecosystem function. And really we're talking about food production, infection disease. Those are things that are so significant to the well-being, which are also particularly relevant under climate change. Again, I have reviewed a number of studies, and again, those tables here are not to detail on any specifics, but to emphasize that studies focus on physiological or morphological changes, like the body shape of organisms, the ability of the organism to take in pollution. Those are also behavioral, whether the way the different species forage or migrate, as well as phenological, which is the time of reproduction. Those are enormous, significant changes that have an important impact on human well-being. And I'll just focus on an example here. So the best known example, as I said at the beginning, is human-driven ecoevolutionary change on the water flea Daphnia, which is a common zooplankton that you can find in urban lakes or urban ponds. Now, has an important role in the food web dynamic in those ponds and lakes. And a predator, which is the alewife, is an anadromous species of herring that is very well known and found in North America, particularly in the Great Lakes, and which determine the makeup of the lake zooplankton, particularly Daphnia. Now, the building of the dams in the 50s landlocked alewives, causing a series of cascading effect on the Daphnia population with evolutionary feedback on the alewives first, as well as on the Daphnia. Oops. What happened? Sorry. Okay, let's see. Okay, we're here. Back. Yep. Oops. I'll get there. I'm sorry about this. Let's see if I can find now the... Just crashed. Rapid. No? This is weird. Maybe if I open it somewhere else. Oh, I can't open this one. Let's see. See if I start it here. Let's hope. No, you never know. So here is describing details the feedback mechanisms. So building the dams stranded some alewives in lakes, creating landlocked populations, and as a result, Daphnia disappeared from those lakes. The landlocked alewives were left with a smaller prey and have evolved a smaller mouth. The evolved alewives led to a further evolutionary change in Daphnia because smaller mouth in alewives resulted in Daphnian population explosion with significant impact on the algae that those water flea eat. In fact, they actually cause lake eutrophication. And has an impact on nutrient cycling, and which evolved to become, the Daphnia become also resistant to cyanobacteria. So this is just an example of the different feedbacks that may take place from one potential stressors, which is this, the building of the dams, to all the way to ecosystem functions. But there is another dimension in urban systems. I suggest that to really effectively represent the complex dynamic of interactions that take place between urban systems and evolutionary feedback, we have to consider also the aspect of co-evolution. And in urban ecosystem, we need to expand the spectrum of phenomena that can cause evolutionary change, including culture and gene-culture interactions. And one of the most very well-known example is the crows. This is crow people co-evolution is one of the best example studied primarily in Japan. Carrion crows in Sendai, Japan are known for placing walnuts in front of cars' traffic signals to actually crash them. And John Marsleff has documented crows-humans interaction for a long time, and as one of his most recent book, very interesting, Welcome to Suburbia, provide a wonderful account of that phenomena. So in this talk, I didn't try to answer the actual question I posed at the beginning, which is, are we changing the Earth evolution? But what I suggest is that there is a series of hypotheses and long-term studies that can tackle this question in a productive manner. In my new book, I advanced the hypothesis that urban ecosystems are not only complex, coupled human-natural systems, but actually they're hybrid. And it's the hybrid ecosystems can exhibit multiple configurations, and as a consequence, their functions can differentiate and evolve, but still maintain their natural functions. So what I see as a potential, as a role of planners and designers to facilitate that change. this is a graphic that highlights how in cities a set of hybrid functions emerge from the interactions among both biophysical and natural drivers and human drivers. And for example, you can look at the flood regulation here and see how those emerge from interactions between biophysical drivers like tides, topography, sea level, as well as human drivers, including the construction of housing and infrastructure, which are controlled by economic growth, and urban development policies, as well as management strategies that we. And you can look at a lot of ecosystem functions in urban system from that standpoint. That interactions generate what I call emergence. And in urban ecosystems, emergence of what we are starting to study are not simply ecological or human networks or built networks, but also are hybrid networks. And here are some examples of, for example, novel food webs, or also from a social standpoint, there are some conservation networks that result from on one hand, people behavior changing in response to the presence and the understanding of evolutionary and environmental changes, as well as eco-evolutionary networks and built natural networks like green infrastructure. Those kind of networks cannot be understood just from the natural sciences or the human sciences. I suggest that cities are essentially dynamic systems that operate on a border of a phased transition between two different states, one dominated by ecological function on top, and one from the human functions. As the country urbanizes, what we'll observe is the ecosystem function is replaced by human functions. And the state of the ecosystem can decline to a point that is so degraded that will not be able to support any more human activities. But in a hybrid ecosystem, what I suggested that novel functions may actually emerge from the interactions between human and natural systems. So those are hybrid functions are the result of hybrid ecosystems that still maintain their original function and at the same time evolve. But what does make a city able to be resilient and change? There is emergent evidence in multiple area of study of complex systems, from physics to ecology to economics, that indicate a system with greater heterogeneity, which means limited connectivity, where connectivity is incomplete, tend to have greater adaptive capacity than those characterized by highly connected homogeneous elements. And I want to give you some examples. So, for example, diversities allow system flexibility. Okay, sure. And the ability to function under a wide range of conditions. A good example is a multimodal transportation system. Oops. When the Hurricane Sandy flooded and shut down a portion of the subway in New York, the flexibility which was inherent in the multimodal systems and redundancy that is available in the urban infrastructure in New York allowed New Yorkers to rely on extended network such as bike lanes, and which provided them an alternative for commuting, as well as allowed volunteers to bypass gridlock traffic at that time. What I call modularity allows autonomous functionality and the ability to contain disturbances and avoid cascadian effect. And here is another example, is the modular electric grid, where the connectivity may stabilize some of the processes, where instead modularity allows for the system to avoid or at least have a safe failure of the system, so the system can fail safely and still be able to operate under certain circumstances. Cross-scale interaction allows functional redundancies across scales and at capacity, again, under contingencies such as a hurricane, creative solution can be found for service substitutions, like energy and water source or delivery of food. And then early warning, which anticipate catastrophic events and allow the system, again, to fail safely by creating warning signals that allow for function to be performed and evolve while they are under failure. But primarily, resilient systems are self-organizing, which is a quality that enable natural and social systems to change their internal structure and their function in response to external circumstances and still maintain their ability to function. So in nature, complex systems from a hierarchical fractal-like structure have evolved in what is considered the maximum internal efficiency. So I believe that a future key of our and challenge for the science of urban ecology and in collaboration with planner and designer is to start to understand and ask the question, do human systems self-organize in response to optimization principles similar to those found in biological systems? It's pretty amazing how, in fact, there is some visual correlation among those two images. This principle observed in complex system could, need to be tested and analyzed. We don't have current evidence that they work in our system, and I emphasize this because this is really a research agenda for the next generation of scholars and students, and I hope there are many students here that take this as their next PhD dissertation or thesis. Here I suggest 5 principles they derive from those hypotheses. They could help designers and planners to help cities build perspective that is from a global perspective, maintain the diversity of patterns and processes to support the diversity of human functions and ecological function, rather than aiming to a specific optimal pattern that we don't know is going to be able to respond in a resilient manner to the future changes. Focus on self-organization rather than aiming to control the uncertainty. Challenge the assumption of current policies and strategies and actively reconfigure systems and problems and policy action, and create options for learning through experiments. And finally, expand the time scale of decision making by designing strategy that will be robust rather than optimal under plausible futures. More than half a century ago, Aldo Leopold wrote of learning to think like a mountain. And today I advanced it. It's the time and the challenge to build cities that think like planets, that we expand the time and spatial dimension of urban planning to the planetary scale. And I'd like to acknowledge my team at the University of Washington for being the source of my inspiration, and thank you very much. Yeah, sorry. Okay, do you want to get out of here? I can take this away. You don't need this anymore. Did I go away? Sorry.
Right.
Right.
Here it is. Let's see if I can show up.
Give you this. I just
Yeah. Okay. Thank you very much. I would like to talk during 2 hours or 3 hours because I think this to think about the city today is something very important, and for me it's also something that I'm really interesting into that today. And maybe the title of my lecture is Form and Function Follow Climate. I have to say that the idea to bring back a climate or physiology or some physical reason into the conversation, I think it's something that when I was a student, it was nobody talked about that. The only thing was about human activity. It's mean about social, politic, religion, or different human production, and then a phenomena appear at the end of the 20th century. There is some new books that arrived, then, like this very famous book of Jared Diamond, a UCLA professor, that bring back an agenda of climate or erosion or some physical reason in the history of human, and to explain like the climate could have a role in how the history go. And then there is this book that explain also that maybe we could destroy our own planet by our activity. And then there is this book, for example, that come today, 10 years ago, and that explain that the war are also linked to climate change, and maybe you heard about this theory about what's happened in Syria that start with a water crisis, with a dry phenomena, climate that was not well managed by the government, and that create the first trouble there. And then there is some new books. There is a lot of book and study today, like for example this book that explain that this volcano explosion create a big disorder in the world. And also it's quite interesting because they explain that the cholera disease appear in India because of the humid phenomena, and then it go to the English people in India and come back in Europe and create like 200,000 people die in Paris or in London in 1830. And so it's why Haussmann and all the people of the 19th century start to create the boulevard and to open air and to change the system for dealing with the water inside the city. So it's quite interesting to come back to some very physical reasons that are at the background of some revolution. And then there is also this book. It's also about a volcano that was like at the background of the French Revolution that create also this bread and wheat problem. And I think why we are interested into that today, because during the 20th century,
all the problem look like there is no more problem because you have air conditioning, you have penicillin and antibiotic, you have oil, you have fossil energy. So it's look like the physical world doesn't exist anymore. We could solve everything. And so we start to think the city like we could do everything because there is no more regulation. There is no more physical constraint. And then in the 21st century, because of the climate change, because of the global warming, because of the energy crisis, we start to bring back the idea that maybe we should think about the climate, we should think about the physical reasons that are at the back, as a basis of the urban design. And I was reading again, like Alberti or Vitruvius' book, and it's quite interesting because there is a lot of chapter about climate reason for example, in the design of the city. Everything is based on the wind and on the solar exposure, but nobody talk about that during the 20th century. We talk only about composition, about form, but this part of the chapter of the book was totally ignored during the 20th century. And it's really interesting to read again and to read all the chapters we forget during the 20th century. And so my work is to bring back this agenda inside the design of the city. And when I was invited in Montreal at the CCA in 2006 for an exhibition with a landscape designer, Gilles Clément, we were both like landscape and I'm an architect. And I proposed this sentence like form and function follow climate because to say that maybe first we could think about the climate and then there is a form that appear and then there is maybe a function that appear. And there is some example like that, like if you take the example of Venice, the city in Italy, there is a problem of drinking water because there is no drinking water, there is no underground water, there is no river. The only source of water is the rainwater. And so all the system of the city is based to trap the rainwater, to filter it on the plaza, and then to drink it on the middle of the plaza. And it's mean all the structure of the city is made by this rain management, drinking system that create a form, the campo, the plaza, and then create a public function. You go there because you need to take the water there and meet the citizen on the plaza. So it's like there is not further design of the form of the plaza, and then people go there to meet. It's first to solve the problem of drinking, and then it creates a form, and then it creates public space. So it's something that during the 20th century, the history was reversed. We forget we reverse the cause and the consequence. We were thinking that the consequence is a cause, but in reality, the cause is the consequence. So, I want to show two projects. One project, very quickly, a kind of master plan for a city. It was a competition in Russia for extending a new district. And so this is like a continental climate. And we start to propose two types of network, like a winter network and a summer network, because it's very cold in the winter and very warm in the summer. So we start to design a first network with street that could let the wind, the cold wind that comes during the summer, inside the street, and that could cool a kind of pedestrian network. So this is like this all this street. So it means the wind come from there, and so the streets are open to the wind, and we have a kind of pedestrian network with courtyard that are protected. I will show that it's protected from the cold wind during the winter. And so it's like you could walk there, you could go by bicycle, or this is like this kind of network. And then we have another network for the winter that is like that, and that that is based that is based on the most to block the wind. And but this is more for the car because we use the car. So we divide in two. Like in two network, like a winter network, like a grid like that, and then a summer network that block the cold wind during the winter and let the cool wind during the summer to cool the city. So this is like, we see the plan, so this is like different type of campo or different type of plaza protected from the cold wind during the winter, and that let the cool wind during the summer going through all this street. And then we create like two plaza, kind of summer plaza here, open to the sea, and winter plaza, like a more urban plaza. So there is a convergence of the two networks there. The most important project we are working on, it's still it's under construction since 2 years now, is a Taichung project in Taiwan. So it was an international competition. We have won with Catherine Mospar, a landscape designer in Paris, and Ricky Liu, Taiwanese architect in Taipei. We won this competition. It's a project for a new district, so it's an old airport in Taichung. This is in the middle of Taiwan. It's a subtropical climate, and there is a new master plan of 2007 by Stan Allen, the American architect, and he proposed to have this kind of central park in the new district with this is some new office building and housing and some public building like Sana Library or Sufujimoto Tower, and there is a conventional center. So, and the park is like the New York Central Park. It's a kind of a green central park inside the city. And when I was thinking about the competition, I start to read the history of the park, of the urban park, and I read the memory of Alphand, the landscape designer of Haussmann during the 19th century that created Butte Chaumont, Bois de Boulogne, and all this green area in Paris, and also Olmsted with New York Central Park. And it's quite interesting because also this is some, we forget this during the 20th century, because when you read the memory of them, it's, for example, Olmsted, in the first page of his memory, he explained that he's proud because the health of the New Yorker is better since there is Central Park, because the park is like a green lung. It cleans the pollution, so the health of the people is better since there is Central Park. So there is really this depollution target inside the Central Park idea, this idea to clean the air, to depollute the air. And by Alphand, it's also the climatic agenda is very strong. It means he wants to bring freshness to the Parisian people during the summer when it's too warm. They could go there and they could cool themselves. And also he explained something that I never really know, why there is trees on the boulevard in Paris. For example, I was thinking it's because it's nice to have trees. And then I understand that in reality it was a device, like shadow device, to cool the street during the summer with a leaf, and to because of the horses and because of the people on the street. So it was like the trees was really like an umbrella, you know. And I never know that. I was thinking it was like a romantic idea to have nature inside the city or something like that. And so when we did this project, we start to do this project, we start to analyze Taichung and Taiwan, and I was talking with some people, and they say to me that they don't like really park, they prefer to go in shopping mall, and there is too much mosquitoes, and it's too humid, it's too warm. And so I was thinking maybe we have to deal with the climate. And when I did this project, it was not so, some people didn't understand why we are talking so much about climate. And it was also our local architect was saying, but why are you so interested into the climate? And we were always inside air conditioning space, air conditioning office, air conditioning car, air conditioning train, and we have just 10 seconds in between the car and the entrance of the building to walk in the real climate. And he say, oh, it's so hot today. And so it was like this type of situation. And because it's humid, warm, and polluted, we propose to work on these three layers on heat, humidity of the air, and pollution. And we start to do an analysis of the site to know if there is already some cold place inside the site, and to know if it is comfortable, if it is the temperature of the air, the climate comfort is based on different parameters. It's based on the temperature of the air, on the wind velocity, on the humidity of the air, on the direct sunlight, on the opening of the sky. So there is some different factors that could say if this place is comfortable or not. And so everywhere it was the same temperature. The only parameter that was changing was the wind, because you could see here that because in the winter in Taichung the temperature is like 20 degrees Celsius, so it's warm. It's still warm. Sometimes it could be 18 degrees Celsius, but in December it's like that. And in summer it's more 30, 35 degrees Celsius. And so there is always a cold wind that comes from the north. There is sometimes a cold wind coming. This is a wind map here, and we know and in June, July, and August, you could see that the main wind comes from the south. So it's not a cool wind because it comes from the south, so it's a warm wind. And we know that when there is a wind, that if the temperature of the wind is higher than 32 degrees Celsius, you have no cooling effect. It's like a hair dryer. So it should be air lower than 32 degrees Celsius. And so it could be only the north wind that have this capacity. So we also analyzed during the June, July, and August, like we take 1 year, and we saw that this red arrow showed the north wind that come also sometime, someday. So we could say that this wind could have a cooling effect, like when you blow on your skin, you feel cold, or when you have a fan, because it evacuates the heat that comes from the skin. And so we did with an engineer, with a Transsolar climatic engineer in Germany, we did a CFD analysis of the site. It's a computational fluid dynamic. So based on the wind and the new district building, because today there is nothing, it's completely empty. It's an airport without any building. So we take the future of the master plan and we do the map of that, and we saw that some area, like the red and the yellow, are more windy when there is wind, and some, like this one, are more without wind. So we could say that, okay, naturally on the future site, it could be more comfortable to be here than here, because here you will have some wind. So this is like a climate analysis, and from that we start to design the master plan. So this is like the form of the first layer. I will explain. We have 3 layers: one about heat, one about humidity, and one about pollution. And we start to design the we transform that into a map, into a composition plan, and then we move to we replace this line, this gradation line, because we say, okay, here it will be a little colder and here warmer. And we replace that, we reinforce this effect by placing a lot of trees where it's already a little cold when there is wind. And we have no trees where it's warm. So it's like we don't fight against the impossible. We just reinforce the existing parameter. And so this is like all the trees location linked to that. And so by adding shadow, by adding evaporation of trees, we reinforce the cooling effect of this area here. And then we propose some climatic devices. This is because we say maybe there is different way of cooling. I will explain that after. And then we propose a function, so it means all the leisure activity find place there. At the beginning, we propose also activity in the hot area or in the polluted area. I would show that, but it was not accepted by the client. He don't want to pay for that. Then there is another layer. It's about humidity, because a new park will receive the 257 hectare new district that is around the park, rainwater that arrive there. And so the park is like a mediator for all the rain that then, because it's like there is a slope from the north to the south, and then it goes to the sea. So it means that this is like a normal when there is some rain. This is the area that collect the rain. And this is if there is an exceptional moment. And so we have worked with Catherine Mosbar on this type of landscape that are creating like pond, like a lake that could create a relief or some hill inside to collect the rainwater, to block the rainwater. And so from that location of the, I'm quite at the end. So from that we create we know that where it's more humid, and so we create some more dry area and we reinforce the dryness. And then we do the same for pollution. We know that we have some big street here that go, we could see that, like in white here, it goes through the park here or here. And so it produces particle matter pollution, PM2.5, PM10, and some other gas pollution, and also noise. And so we could say far from the road, it's less polluted, it's less noisy. So we propose to increase that by placing trees that absorb pollution with hairy leaves or big trunk that reduce noise. And then all the family, the children playground take location in this far from the street, less noisy and less polluted area. And then what is very important, all these three layers are overlapping, so it creates a diversity of microclimate. So we don't want to have only a good climate and to banish the bad climate. Because we have, for example, sometimes it could be cold, dry, and polluted, or it could be cold, dry, and non-polluted, or it could be warm, dry, and polluted. So by overlapping these three layers, it creates a random configuration of microclimate. And of course, one microclimate will be very good in the summer at noon, for example, the cold one, but during the winter at 6 p.m., it will be better to go where there is no tree. So it gives a variety of microclimates, and there is not only one good things. And then we have the main road connecting this. We create a kind of isotherm line. So there is a cool path that connects all the coolest area of the park. We have the dry path that connects all the dry area and all the sport activities, and a clean path that collects all the children and clean area. And I think I have only 1 minute more. So I just want to show, like, this is some image. 5 minutes? Yeah. Okay. So this is a site under construction. This is all the drainage and things like that. This is some bridge and tunnel. So it's quite big. This is we are in the middle of the park, and this is the end of the park at the building. And the dry pass, for example, is more like this is here we have the dry pass. This is the sport pass, so it's more complicated to take it. You have to be like a sport player. The leisure pass, the cool pass is more like a soft promenade, and the clean pass is very flat. It's for baby car or wheelchair. So there is like 3 types of walking through the park. And very quickly, this is we have 3 types of pattern for placing the trees for the cool, what we call the clear area, or the cool area. We have 3 types of. We have 1 type of placing the trees like a regular grid. So where it's cooler, we have a lot of trees, so it creates a lot of shadow and a lot of evaporation. So it's like we increase this kind of cold phenomena. And we have proposed to have sometime these black dots that are like a little like in the park. You have not only trees, you have sometime a grotto or a pavilion or a gazebo or a fountain. And you could understand all these elements of the park like some other way of cooling, because a grotto is like going inside the inertia of the inertia of the ground. A fountain by evaporation cool the air by changing of phase from liquid to gas, or a pavilion is something that protects from the sun. So this is like diverse way of doing that. And so we have some different type of what we. So this is the type of trees. Also the type of trees we choose precisely trees linked to this cooling effect. So we have trees that have a lot of leaves, or big leaves, or white leaves to reflect light. And then we have these climatic devices. That this is the size of the trees. And we did a catalog of all the technique for cooling. So we have like convective cooling by blowing. We have evaporation cooling by changing liquid to gas and taking the energy during the physical change. We have radiative cooling, and we have some, this is like a solar chimney, or we have some other type of solar cooling. And I just want to show one device. So all the energy is only green energy. So there is no fossil energy, no nuclear energy. It means we have some passive and active device. And the active device we propose to use like a Palladio geothermal cooling. Like we take the air, we go underground. We did some analysis on site. We know that we have all the way 25 degrees Celsius at 5 meters down, when it could be 40 degrees Celsius there. So we go underground with the air. We need a fan to blow the air, and then it's cool the air, and we blow the air inside the park. And we have 7,000 square meters here of PV panel. The client asked us now to have also 5,000 square meters on the south of the park. And this PV photovoltaic panel produces all the electricity for the lighting, for the building, and if there is still electricity, we use it for activating the fan in real time. So it's good. It means when it's very hot, there is a lot of sun, so there is more electricity production, so we could activate the fan. And this is some research we did with the engineer to calculate the amount we want to blow air inside the park. And we calculate the amount of air, the speed of air, depending of different moment of the year with different type of humidity rate, wind speed, and temperature of the air. And in order to see the effect, to have a kind of effect, large effect there. And so we have this fan inside this, what we call the cooling plants, and then we have underground ducts that go and to the different device. And so this is like under construction. So this is like the climatic plants. So we have the machine inside this. So we have guarantee and maintenance, easy maintenance and good guarantee of that. And then the pipe go down, and it's go to this device. Like for example, we have the anticyclone. So it's the pipe arrive and it's go there and it's flow. This is a 3D model, and then one. And then here we could see the underground pipe, and that could here. And we have that, and at the end we have the. So on this picture there is no trees, but it will be completely inside the trees. There is trees, but they have no leaf and they are small. And so there is another one like evaporating cooling with this kind of cloud. Or another one is like quite interesting for me. It's like cold light. So we analyze, this is the heat coming from the sun. 50% of the energy of the heat come inside the infrared, 50 is inside the visible. And inside the visible, the green and the blue wavelength is more heat, they contain more heat, and the purple one is a low energy wavelength. So we propose to have only like the coldest color of the light with this type of device. So this is some analysis like that for different. And then this is for example, the choice of the trees for the clearia. So this is the depolluting trees. We choose trees with hairy leaves and or big trunk, porous trunk, or some different type of trees that could have a depolluting effect. And some depolluting device like filtering the PM pollution. And to finish, just we have every 50 meters we have a sensor that measure in real time the temperature of the air, the humidity, the pollution, all the pollution. We create an index by additioning all the different parameters. And so in we have this, and then we have a smartphone application. So it means we could go there, and in real time you could see the temperature in the park. So you could decide, okay, if it's warm, you want to look to the coldest area, so you go there, or the less polluted, you will get the real information in real time, so you could go where you want. And so we have different buildings, but I will stop now. Thank you.
Okay, thank you. I will ask Francois Guest to the podium. Karen McLathery, you know at the School of Architecture, she's a professor of environmental science. Yeah. Associate Vice President for Research, Sustainability, and the Environment. She's the director of the long-term ecological research program based on the Eastern Shore, and her work is devoted to environmental change in coastal marine systems. Gina Ripple is an assistant professor in the School of Architecture and founder of the UVA Design-Driven Manufacturing Initiative. Her background is as a professional hacker, don't know if you say that in an interview, and a computer science engineer. Matthew Joe has an MArch from Harvard and is a PhD in geophysics and has an office and is the head of the Arctic Research Group. So we have a geophysicist, hacker technologist, and a coastal ecologists to consider what can be drawn between the work of Marina Alberti and Philippe Rahm. But Philippe and Marina, I invite you also to come to the podium. So our time, we're not bad, we're a little bit over. I thought I would ask perhaps Karen if you would like to pose the question.
Should not have sat at the right. Do you want me to use
Yes.
Does that work?
So,
Marina, I had a question for you. As an ecologist myself, I work on natural systems. One of our biggest challenges in thinking about future scenarios of change is to understand whether responses are linear or nonlinear. And I know you addressed that in one of your big questions about thresholds and crossing of thresholds. And I wonder if you could elaborate a little on that idea about thresholds and how it relates to cities and urban design and planning. And also touch a little bit on the point you made at the end about early warning. So how do you think about that in your urban ecology framework?
Thank you very much for this question. I appreciate that is probably one of the most challenging problems in ecology and in coupled human natural systems, because we have some evidence from observations of regime shift in ecological systems. Again, I say some. For example, we know how much phosphorus we put in a lake that basically shift from a clear state to a trophic state. And we generally, based on that, can start to design and plan or anticipate potential regime shift in that system. The problem with regime shift is, to clarify, is that when there is a state change, returning to the previous state does take much longer and much more energy and effort than if just by taking away the phosphorus or any nutrient that we put in the lake. So just to understand the complexity of that. Now the problem is that in coupled human natural systems, like in cities where there are natural processes and human processes, we know very little about thresholds. So the reason why I emphasize the importance of proactive actions, and when I talk about scenario planning and I talk about designing for robust strategies as opposed to optimal strategies, that we don't know the future. And as much as we use predictive models are limited in the ability of actually detect those changes. Why? Because predictive models are based on observation from the past. But if you just look at climate change, the observation and we try to predict the phenomena of climate change using the observation of the past, we would not be able to understand where we are headed now. So a robust strategy and a scenario planning strategies aim to identify what are the alternative, possible, plausible futures and design strategies that may not be optimal on all those plausible futures, but will be robust. And no matter what happens, we will survive as a species. So again, this is a planning or design strategies to deal with an issue of thresholds that we need to start to study more experimentally.
Thank you. Gina, would you like to follow?
Let's see. I think this one's on as well. So, I mean, I think that this conversation gets at the heart of it, that in an audience of designers, we're looking for mechanisms to respond to the issues that you're raising. And so I appreciate very much that, you know, at the heart of that is how much can we be predictive, how much can we design flexibility, and we know that, and at what scale. And we know that our infrastructure produces some lock-in effects well, maybe others can have a kind of degree of flexibility. So I was thinking about that as I was listening to your presentation, Philippe, and what I really appreciate about the project you showed at the end is that you were studying all of these systems, but then not trying to neutralize them. You were allowing for diversity to exist. And so, so one of my questions for both of you, and maybe for Marina, is so you talked about these habitat modifications that you've found have an influence, which I found really interesting. You know, when you really zoom in, what are the habitat modifications that are creating an impact, like CO2, levels of metals, lighting, heat island, food? We can't eradicate those problems. Do we try to emphasize their diversity so we can maybe say, okay, we have a concentration of CO2 here, now we're seeing an algae bloom, we have to shift something in order to move that concentration? I mean, do we try to emphasize the diversity rather than minimize the problem?
You know, I have to say, I really appreciate also this question, because when I was listening to the presentation, also the last presentation, I realized that there is so much in common that we can build by starting to work together. And especially this last discussion about a climate sensitive, how we can build a climate sensitive city and building and park. And I was thinking that one connection to what your question is that yes, we need to emphasize and allow this nature to operate at its best for humans and ecosystems. So I was thinking, like, among the layers that you were describing of the sensitivity that we could build a park upon is, first of all, one is the climate, but there are also other biophysical layers that could play out very well. And climate is a very good start and already quite complex, but there are others. And then the other thing was, you're designing a park with in mind the human comfort, which is one human function. But I was wondering, could you add, if we start to think about coupled human natural system and facilitate what you said, the ability of other species to survive well with humans, can we add a layer also of natural functions that could be emphasized within the city, so that we maintain both? For example, the choice of trees, great. Trees that reduce pollution. What else we can think about when we choose trees with respect to ecological functions? And so I thought this was amazing, the connection. Although it seems like our talk were one on one planet and one on the other, I actually think that there is a very good connection.
Yeah, I think of course there is different layer we could add, like a animal layer, or like a bacteria layer, or and for example the lighting system of the park is based also on the animals sleep, so we have like something that like linked to regulation for traffic and people on the edge of the park, linked to the street, and more we go inside the park, more we have something linked to animals, biocycle, sleep, things that don't disorder, so we could do like that. But what you say, what is important to understand, that you are at the beginning, the people only think about trees like they like these trees, or they like the color of the trees. The choice today is more like that. This is like, and to change from a kind of cultural, aesthetic point of view about the choice of trees to a kind of ecological point of view or climatic point of view is already a big change. So this is Matthew.
Hi. Thank you for two really amazing talks. Super interesting, and I kind of they were sort of bringing up a whole series of ideas, thoughts, and reactions to see the very different frames and ways in which you're working. Marina, actually, when you started to speak, this idea of what does the future city look like, you flashed very briefly a slide that was this Tabana cloud city from episode 5 of The Empire Strikes Back, right? And I was like, that caught my attention. Because later on we're talking about mice and adaptive ecologies, and then I started to wonder what does she really want for what does the future city really look like, and then when I looking at Philippe's synthetic environments and this idea of as Philippe, as you're talking about the park and it's an amazing systems and really for me your work in a sense is kind of like Italo Calvino but translated into thermodynamics. How do you see the city from a very, very different, this world that is sensorially and physiologically very intense and also very responsive. But I can't help but think, do we inevitably, in both of your views, do we need nature? Do we believe that the future of our cities is just purely synthetic? And do we actually need to be inclusive in terms of ecosystems? Why can't we traveled to the moon and we survived? We were trying to go to Mars and, to create new. So why do we need nature? And is that something that you see as inevitable, that we have to create this inclusivity, or should it just be, let's march forwards, let technology prevail, and whether nature survives or not, as we know it in the past, we give it or leave it.
No, I think the nature is, from my point of view, the nature by itself, it's not a romantic idea. It's more like an ecological idea, to be part of the cycle. We understand, for example, when I talk about the cholera, the disease during the 19th century, it was linked to a kind of ecological change that produced some disease, and so we are completely dependent of this type of ecology, and so we could not escape from not nature but from kind of bacteria to weather system. So it's not. For example, there is a kind of the risk is the greenwashing too. For example, in Paris, there is a big important competition last year about rethink about Paris, and everything was about green. So it was full of trees, full of green facade, and we know that this is the risk is that it's become a romantic ecological idea of green of the city. Because, for example, we know that if you just add 20 centimeter of thermal insulation more on the building, you do more for the climate than adding a green plant on the building. Or if you add a white roof, that reflects the radiation, by a high albedo, you reflect the overheat into the universe, so it's maybe better than a green roof. Of course, the green roof have a good effect for rain management or some other. But I mean, we don't have to be naive and to be to go into a romantic idea of that. We should bring science and knowledge and into the discussion. And it's absolutely not about romantic idea.
Thank you for more provocative questions. First of all, let me clarify that the image from Star Wars was my child who helped me with that slide. I put it there not to provide any future of the city, but actually to ask the question, what futures we are not imagining? Because we are kind of locked into a vision and archetypes of what's the future that are based on our previous experience and history, but can we start to go beyond that and ask questions that we haven't asked for a while? One is, why do we need nature? I would say, why and whether, I would ask whether nature needs us, which is a much more radical question, because I wanted to also clarify and remind ourselves that we are nature. And that idea, the idea that we are separate from nature, is what has brought us here in terms of the problem we're dealing right now. Is that we are nature, we're just one other species. And I hope we are a species that are able to do better than the microbes billions of years ago have made to turn this planet a planet where we could have life. Can we actually evolve to another planetary system, meaning the Earth, with a different way in which technology may play an important role? But we do depend on nature for the technology to work, or at least even a transformed nature. So that's my answer.
So maybe I could just add something. Bruno Latour, there is two important philosophers today, like Peter Sloterdijk and Bruno Latour. I think they talk about the relation with the object, like the subject and the object. And they say before the object was in front of us, like the nature is in front of us, or the trees is in front of the. But today we are inside the nature, or the object, we are inside the object. It's, for example, to give an example, it's like a baby bottle, it's an object, but you drink it, but maybe the chemical quality of the plastic will go inside you and create some trouble with your own physiology. So it means the object have also kind of microscopic effect on you, or macroscopic effect. So there is this idea that we are inside the object today. We are. So it means, like you say, we are nature. We are inside. There is no more distinction between the subject and the object. We are in the same. We are sharing molecules and sharing bacteria and sharing chemistry.
Yes, shortly, and then I'm going to come in.
Yeah, and that's actually that's interesting because it makes me think of James Lovelock's Gaia here, which is basically. If some of you, if you, I'm sure many of you know this, but the idea that the Earth is, Mother Nature is actually real, and it's a kind of, the Earth is living, but it makes me think that are we this, sort of as the new Anthropocene, this kind of era, where we are, as Philippe is talking about in his work, generating our own reservoir of energy, and also our own, in addition to the biosphere, the atmosphere, the geosphere, that somehow we are a new component in this larger Earth system. And the question is how do we negotiate the equilibriums or disequilibriums, I guess is. But I wonder whether the Gaia theory needs to be sort of revisited in some ways to understand how we're influencing it.
Well, I think that, I don't know if you want to, let me just say there's a key concept in your work, which is co-evolution of urban development and ecosystem function. And I think I would like if a little bit of the conversation carried on with that. You showed a slide, I didn't get the Star Wars, but I got the half of Manhattan is happy green, and is that a suggestion of what you might mean? If there's an equivalence in area, and what is that green half? What do you mean by that? It's as if I was to say to Karen McGlathery, who works on the coastal ecosystems on the eastern shore, so not in an urban setting. Karen, does it work if in Hampton Roads we just import those coastal ecosystems, and can't you make them work so that there's some kind of coupled human-natural system functioning in an urban context? And I think that's, as planners and designers, the co-evolution of these systems, urban and natural ecosystems, is what seems to be a critical question. And I know you may not give us a very detailed answer, because it could only be an unscientific answer, as you say. Nevertheless, from your point of view, what might it be possible?
Yeah, I think we've all made the point that these are complex adaptive systems, and you can't separate people from the natural built systems. And that's sort of pervasive through all disciplines, ecology and architecture and geology and biology. I think that
even though I work in rural environments and natural systems, I cannot understand how those natural systems work unless I put people into the equation. And just in the same way as in a city, you can't understand how a city works unless you put natural systems in the equation. And so very much there is this transcendence of ideas and theories and methods between the two. So I don't, the idea of the Anthropocene is something that I think we all agree about, that we now are a force of nature that on the planet that we haven't been previously. But I would also revisit Gaia. One of the big issues about Gaia is that it said that there was some kind of homeostasis or equilibrium that we were to reach, or some optimization. That's not the case. As Marina said, it's all of what we're trying to do is come up with plausible future alternate scenarios that embrace the uncertainty rather than run from it. And so whether it's a planner or an ecologist or a political scientist, we all have to sort of ask that same question.
I have a, there's one other, well, there are a lot of interesting points we could respond to, but one that caught my attention is particularly this week, your statement about wise citizens rather than just smart cities. And, if there's one thing we've seen, it's that these concerns, this awareness, is not shared by as many people as we would like. How do we, or what can you say to this group of designers and aspiring designers, and about how do we broaden our mission, our impact? What creative ways are any of us seeing to create an environment where we have this emergence is enabled by wise citizens? And there's one example that came to mind. Jose Sanchez at USC has been working with SimCity to create a game that allows children to kind of use energy-saving technology, wind turbines and things like that, and that affects how successful the city is. So do we need to focus our energy on coming up with a habitat version of that? Or, what are the other ways we can think about broadening the audience? And that's for anyone.
Do you want to answer, or Philippe? Because I think we're going to turn to the audience, but I'd like to just say, Philippe, we first know your work with exhibition pavilions, houses, and today we saw the park in great detail, and it makes one wonder if you, at the same time, are designing, have the commission to design the buildings in one block or more blocks, or you are directing the architects on those blocks. What is the kind of synergy or interaction that you might foresee, or that you want that architecture to do or be relative to what you have proposed for the park?
We were in charge of the urban design, for example, for placing the public building, like the new library or like a museum and conventional center, things like that. It was like we adapt the standalone master plan. That was the first one. And then, because our client is a Taichung government, it's a public commission, and all the other part will be private. So we have it's already on sale, you could buy it. So this is some block, and we are not linked to that. So this is, and I have also some building inside the park, like a visitor center or maintenance center or something like that, and we try to adapt the same strategy inside the building. So, yeah.
Okay. So I would like to propose 2 or 3 questions from the audience. Would anyone like to ask something?
I've thought for a long time that, well, maybe it's a little bit negative to say, but that the human is kind of a flawed and kind of problematic species. And I wonder, well, we've seen this, but I wonder what your optimism is about the possibility of orchestrating human action. The wise citizen or the citizens that engage these kind of parks and actually experience the climate rather than jumping from one air-conditioned space to another. What hope do you have for kind of humans kind of engaging kind of the environment they live in? We live in.
About the climate, it's quite clear, because there is a balance between the CO2 and like gas and the absorption with the plant, and because we burn a lot of fossil CO2 carbon, so we add some very old carbon that was no more in the ecological cycle. So it's why it's changed the climate, and so it's very clear, from 20 years when all the studies start in all the university around the world, and also in Switzerland, in Lausanne, we were aware about that, and so we know that we have to stop to use fossil carbon energy, because we are doing so we have to use what we call green energy, non-carbonic energy, and like geothermal energy, solar energy, wind energy, hydraulic energy, and I think it's a great opportunity to change, and we have to do that. So this is quite simple, but of course it takes time, because a lot of things. I was in China last week. It was a Beijing forum with some important people from everywhere, and I was at the table with an economist, American guy. I don't know who it was, but he was working on petroleum, things like that, and he explained me that the problem of the fossil energy, that we made too much infrastructure when the price of the petroleum was high, and today we have to reimburse, and so it's why we could not. Nobody want to leave the oil before 20 years, because we need to pay back the money, that it was invest. So there is a lot of phenomena, involved in that, but we need to change the energy, and I think it's a very good challenge, and it's really interesting also for an architect, and to change completely that, and we need to have this transition.
Can I actually just come back to Lucia and Gina's point? I think, based on the sensibilities and the super smart nature of how you're operating in your work, I guess the question is, how the hell do we deal with a government that is currently filled with climate change deniers, and what do you do with the future generation of youth and young, so that the ideas that you're talking about can be communicated in a broader frame?
When the morning after my child was crying about his future in this country, I tried to figure out what I could say. And one thing that came to mind immediately was, 4 years. That's not too long if you think like a planet. So what I told him is like, think on a longer time scale, what we need to do to engage for that, the next generation. I think 50 years from now, because my child will be my age 50 years from now. And I want to make sure that his future is possible on that time scale. So yes, it's not simple. It's even, it's always returning back. But my question is, again, back, does nature need us? Because if we are not able to take the challenges that nature is posing to us, we will be out of here quite soon. Cooperation is one of the criteria for which species, cooperative species are known to be able to live further and more. So I do believe that humans have to make a choice. And I'm not saying that everything is fine. I'm just saying we have the opportunity, and that's where my hope is, to be able to do that. But we may not able to take that opportunity. I hope we do.
So I have a request, as we're particularly talking about this political moment, and we're talking about human players, that when we're talking about individuals, we actually perhaps talk about residents rather than citizens, because citizenship is a particular legal status that not all human players are able to have.
Does anyone have to say?
You know, I think you said well. Don't need to.
We're going to come back to that, I know, in the Margarita's, the fourth table, and that's at the heart of the idea of the commons. So that's not good that you bring that up. And we'll, maybe we'll say we're going to be getting to it.
Hi, my name is Brian Owensby. I'm from the history department. I come here to be optimistic because as a historian, what we do is tell the tale of qualification, if not wreckage, and of the inherent flaws of almost all human conceptions. So from in that spirit, I have a question particularly for Marina. One of the things I found interesting about what you said was the centrality that you gave the notion of self-organization and by extension self-correction in your list of principles. It is to me ironic that we should be talking so much about self-organization and self-regulation these days. The historical source of that idea is actually not in ecology. It comes from economics, and particularly the end of the 18th century, Adam Smith, and the idea that economies self-organize and self-correct. And with all of the qualifications, look where it has gotten us. And so I wonder if there isn't a tension at the center of the principles that you are articulating. It's not clear to me, as a proposition, what role self-organization and self-correction should be playing in all of this, given that we are not Daphnia, but rather creatures that in our ecological niche approach this thing that we get to call nature. Daphnia doesn't really have a term for nature. Affects the way in which we approach what we do. And to think in terms of a self-organizing system is already then to beg a whole bunch of questions about the role that human consciousness plays in the decisions that we have to make. It's tortured, but there's a question in there somewhere.
I totally follow your question, and I appreciate it. It's a really tough question. In fact, one of the things that I have been challenged with is how in a self-organizing system a designer or a planner, what's the role of a designer or a planner? Because planning and design assume that there is some kind of director of the orchestra, someone who directs where to go, where in a self-organizing system, everything emerged from the top, from bottom up. The question I see is that you're right. Human intention changes the rule of the game of the self-organization. And so that means that our capacity to engage in a self-organizing system by introducing new knowledge and new experience and new memory is critical. That probably other species is a capacity they didn't have. Okay, sorry. It was a capacity they didn't have. So definitely there is a tension that can be, in an optimistic manner, be resolved only if we start to appreciate that self-organizing system, start to understand how self-organized systems operate. And I had to say that in 100 years or more of history of planning theory, in design theory, I don't think we have understood and incorporated self-organization as the central mechanism by which human and natural process operate.
Okay, we're going to come back to that, sure. I think we're going to do one more.
Yes, thank you. I actually wanted to offer something of a small corrective, perhaps, to one of the sub-themes that has emerged so far. And that has to do with this disparaging of Romanticism as a worldview, as an intellectual history. Because I think even some of the ideas that were brought forward as being very, very new in these presentations are actually quite old. For example, the notion of subject-object identity in Romanticism. If you look at somebody like Schelling and his Naturphilosophy, simply as one example. The idea that mind and intelligence are actually very broadly distributed in the material world and not simply our province. So I think it's worth revisiting some of these deeper histories as we think moving forward. I think one of the advantages, perhaps, too, in looking at that movement since it was brought up, is that many of the scientists of that day, including Goethe, thought of their work very much in conjunction with poetry. And I worry for the future that if we rely purely on technocratic solutions, we're going to miss it. Because I think we don't have poetry going forward, it just may not work.
All right, okay, I think we close on that one. Thank you, Michael. I think we close on that one. Philippe is ready to go for 2 more hours, so am I, but unfortunately it's coffee time and we've got something good coming up soon.
About 15 minutes.
Yeah, 15. Out. Thank you very much. Thank you very much. This could go for a long time. I think if you had showed, I was going to go up to the podium.